Good afternoon, ladies and gentlemen. Welcome back to the room. I trust for you had a nice conversation over lunch, and also very interesting interaction that are happening at the end of this room to exchange information on technologies. That's really nice. In this afternoon, we're going to jump onto the TEEP report. This is one of the important milestones for the negotiations, as well as the mainstreaming life cycle refrigerant management in the discussion of the Montreal Protocol, as well as countries' efforts domestically. And we actually had the really nice presentation at OEWG 46 in Montreal a couple of months ago. And we understand for not many of you were able to attend the meeting in Montreal, so that we have extra gift from one of our distinguished TEEP task force members, Miss Hilde Dont. She's the co-chair of the TEEP task force on decision 35/11 on life cycle refrigerant management, and a member of refrigeration TOC. So that she's going to walk us through the contents of the TEEP report that was just delivered in this year. And then also we are very lucky that we have discussion. But before that, very importantly, I am going to introduce Nathan, who has been your important friend in the ozone community. Nathan, can you come up and introduce yourself, please?
Good afternoon, everyone. I'm very happy to see you all here today. I apologize I was unable to be with you this morning, but I'm committed to being here for the remainder of this exciting workshop. For those of you who do not know me, my name is Nathan Borgford Parnell, although I go by BP. It's a little bit less of a mouthful, but I respond to both. I lead the Science Affairs program at the Climate and Clean Air Coalition. And previously, I led our efficient cooling initiative at the CCAC that Makoto was one of our leads on. And I've been involved in the Montreal Protocol for an embarrassingly long time, I guess. Actually, I'm becoming one of those gray-haired sages who can reflect on the history of the Montreal Protocol. And I'm your facilitator for the next two sessions. And I want to get out of the way very quickly for the excellent presentation from Hilde Dont, but I wanted to take an opportunity very quickly to reflect. I've been involved with the Montreal Protocol since 2006. I got involved at the tail end of the negotiations for the accelerated phase out of HCFCs. And when we completed that, I recall the community started looking around at what we could do next to save the world. Montreal Protocol being the most effective environmental MEA in history, and we were excited for the opportunity to tackle the next big problem. And the two big problems that came up were HFCs and banks of refrigerants. And I remember the discussions back then. Obviously, both of those were critical problems in 2007, 2008. And we thought, you know what, HFCs, I mean, we did the HCFC accelerated phase out. It was just a couple of years. That was an easy adjustment. Why don't we try expanding the Montreal Protocol to manage HFCs? How hard could that possibly be? It could only take us a year or two to negotiate that, and then we can get to the really sticky problem of banks. How foolish we were in retrospect, because 9 years later, we finally negotiated the HFC phase down Kigali Amendment in 2016. And when I look back at that, I mean, I'm actually heartened by what's happening in here today by virtue of the fact that although banks have become a larger problem in the intervening years, back when we were discussing banks, there was never any discussion of the life cycle issue. There was never any discussion of a systems approach to managing banks. There was never really a net zero and systematic approach on the table for how the Montreal Protocol could potentially address that issue. And in the intervening years, this issue has been allowed to bake. Communities like your own, particularly with the leadership of Japan, have really taken on this issue and thought about it and taken the time to understand and sensitize the broader global community on this issue, that this is not a discrete issue that we can deal with at the landfill. We have to be thinking about the whole to how we're dealing with refrigerants in the appliances and other equipment that use them. And so that is why I'm particularly excited to be here with all of you today and to hear a little bit more about this excellent TEEP report on this particular issue, because it shows an enormous evolution in the conversations in the Montreal Protocol about how to manage this issue from a systems approach. And I think that's really the right way to go about it. So without further ado, I would like to introduce my distinguished colleague, Hilde Daunt, who is a co-chair of the TEEP task force on this report, 3511 life cycle refrigerant management report. So Hilde, please.
Thank you and good afternoon. As Mr. Kato said in his introduction, I'm very pleased that I get the opportunity to talk you through the report we made at the OEWG in Montreal on the task force report for life cycle refrigerant management. For a few of you, this will be for the second time. I hope that's okay. I also heard that the hotel has some fire safety exercise this afternoon, so I hope there is no alarm going off during my presentation. But if it does, the hotel said to me that we can stay in the room and you don't need to leave. So with that, I would like to start my presentation. And I hope that works. Okay, here we are. So what is the background of the report? Actually, the parties to the Montreal Protocol decided or requested the TEEP, the Technical and Economic Assessment Panel, to prepare a report to be presented at the OEWG in Montreal on 4 main elements. The first request was to describe available technologies for recovery, leakage prevention, recycling, reclamation, and destruction of refrigerants, as well as their accessibility in parties operating under paragraph 1 of Article 5 of the Montreal Protocol, including regionally specific approaches. We have covered the leak prevention technologies in Chapter 2, the recovery, recycling, reclamation, and destruction in Chapter 3, and the accessibility in Chapter 4 of the report. The next request was to identify obstacles and challenges associated with effective leakage prevention, recovery, recycling, reclamation. I will shorten it to LRM. That is covered in Chapter 6 of the report. And then there was a request to elaborate on the costs and the climate and ozone benefits associated with LRM. This we have covered in Chapter 7, which was about cost and financing. And Chapter 8 is about the climate and ozone benefits. And then finally, there was also a request to collect some examples of policies, incentive schemes, such as producer responsibility schemes, good practices and lessons learned. And this we have covered in Chapter 5 of the report. The task force consisted of 22 members. As you can see, they come from Article 5 and non-Article 5 countries. We had a reasonable fair gender balance. And we had experts from all over the world. Some of them are also members of the technical option committees of the TEEP, and others were external experts that were specifically added here to this task force. We had to work very hard in a very short time. We started in January and had to deliver the report by April. It ended up with more than 120 pages. I really recommend to read it. So it was a hard work for the whole team. So in short, what is life cycle refrigerant management under the scope of our report? We call it a comprehensive approach to manage refrigerants in the refrigeration, air conditioning, and the heat pump sector. From the original design of the equipment, the installation, the use, the waste phase, through to the reuse or destruction of the refrigerant. Of course, with the aim to minimize the direct emissions of refrigerants and increase refrigerant supply through 4 sets of measures. First of all, the prevention of refrigerant leakage. Secondly, the recovery of refrigerant during servicing and end of life. Thirdly, the reuse, either through recycling or reclamation. And finally, destruction. So let me take you through 4 of these topics one by one. Leak prevention first. Leak prevention focuses on the measures to avoid the refrigerant loss during the whole RAC HP life cycle, which of course has climate, ozone, and other environmental health and safety benefits. It also provides energy savings by maintaining the performance of the RAC HP equipment. Leak prevention requires a variety of preventive actions during the original design of the equipment already, the manufacturing process, the transport, storage, installation, use, and end-of-life treatment. There are a lot of international standards and other guidelines, including national ones, that provide recommendations in this regard, and you can find several of them in the report. Examples are standards that identify the selection of suitable materials, such as components, joints, and packaging, training requirements, and also tightness inspections to verify that the refrigerant indeed is not leaking. And for tightness inspections in particular, there are 2 major group of methods that are being used in the market. The direct methods, as we call them, these are by use of sensors or subsets of UV dyes or acoustic cameras. And indirect methods, they are focusing on analyzing the performance parameters of the RAC HP equipment, such as the pressure or the temperature, for example. Leak tightness inspection has to be achieved through comprehensive training of the technicians, of course, the accessibility to those leak detection equipment, and policies that promote this regular inspection and repair. Leak detection technologies are available, but the report identified that they are not always accessible in Article 5 parties, and examples of supporting policies are provided in Chapter 5. Focusing on refrigerant recovery, I think all of you in the room know this very well. It refers to the recovery of the refrigerant from the RAC HP equipment, also from refrigerant cylinders, during the servicing or the disposal. There are off-the-shelf recovery tools. I think some of them are promoted here in the room. There are also custom-made recovery technologies that are available, but again, not always accessible in Article 5 parties. Refrigerant recovery is, of course, essential. Otherwise, recycling, reclamation, or destruction could not take place. But it remains low in both Article 5 and non-Article 5 parties. It really requires a change in behavior to stop venting to the atmosphere through comprehensive and continued technician training, access to refrigerant recovery machines, establishing also a logistic reverse supply chain with sufficient access to refrigerant recovery cylinders and tanks. That should really not be underestimated. There's a need for sufficient technician time to complete the recovery and financial mechanisms to support this responsible recovery. Refrigerant that is recovered can further be reused by either recycling or reclamation. And to determine whether a recovered refrigerant can be reused and where, it may be necessary to conduct a chemical analysis to know its composition. But in some cases, the reuse may occur immediately without prior treatment. Refrigerant reuse is very interesting as it does not count to Montreal Protocol consumption targets and therefore can contribute to compliance. Both recycling and reclamation support the circular economy by reducing the need to produce new refrigerants. And incentives for recovery and reuse are highly sensitive to the size and accessibility of the bank of refrigerant in rack HP systems, the regulatory environment, availability of alternative technologies, and to the price of virgin refrigerants. In particular, if you have a phase out or phase down regime that creates a shortage of refrigerant and leads to price increases, then refrigerant recovery and reuse may increase because it's economically more interesting. However, if the supply of newly produced or virgin refrigerant remains plentiful, then the reused refrigerant may be non-competitive and other policy and economic measures may be required to incentivize LRM. What is refrigerant recycling and how is it different from refrigerant reclamation? Refrigerant recycling is a basic cleaning process such as filtering and drying. It often occurs on site and is most suitable for single component refrigerants. And in the picture, you see an example of a recycling machine for 134A in the car industry. Refrigerant reclamation is at a higher level, it's a reprocessing and upgrading of refrigerant in order to restore the substance to a specified standard. It can be through mechanisms such as also filtering, drying, but also distillation and chemical treatment. It often involves off-site processing at a central facility. And the reclamation of blends presents particular challenges, as in some cases, composition changes. It's also true that reclaimed refrigerants may need to be mixed with new refrigerants or reclaimed single component refrigerants to meet the required specification. And in the picture, you can also see two examples of reclamation facilities. It was mentioned already this morning, some recoverant refrigerants need to be destroyed because they may be highly contaminated or there's no further market need. The Montreal Protocol has established a list of approved destruction methodologies. This is mainly for the purpose of production data reporting. It was found that there is actually adequate global capacity for destruction, but it is unevenly distributed between non-Article 5 and Article 5 parties, and even between Article 5 parties. It can be anticipated that destruction technology may further improve in cost, scalability, mobility, and efficiency. Then a few words on the costs of LRM. It requires substantial investment for the acquisition and operation of leak detection, recovery, recycling, reclamation, and destruction. It depends on the type of refrigerant, the scale of the operation, regional regulations, the technology used, and the fate of the recovered refrigerant. Will it be reused or will it be destroyed? Recovery and recycling is relatively simple and dispersed over many places. To be effective, you need, though, a large amount of recovery and recycling equipment. Equipment for destruction and reclamation is more sophisticated. It can be capital intensive and is more centralized. Costs include capital, variable costs, such as labor, and opportunity costs. For example, an installer may gain more money if he goes to install a new rack HP equipment rather than spend his time on recovery of a refrigerant. And that's what we call the opportunity cost. Is it really opportune for him to do that work or not? Variable costs are determined by the volumes of the refrigerant being recovered and reused. In the next slides, there is an indication of prices for LRM technologies. The parties have commented that in their country, it could be quite different. It could be higher, for example. It depends on import duties, local distributor price settings, and so on. But to give you some indication, the cylinders of refrigerant for the smallest cylinder could be less than $100. Recovery equipment between 300 and 1,000 for basic recovery equipment. But if you go to higher capacity, it can be up to $30,000. Handheld leak detectors, about 400 was the indication. Recovery and recycling machines, 1,200, but depending on the capacity, it could also go up. Refrigerant identifiers, I think some of them are also featured here in the room, between 1,000 and 5,000 US. Gas chromatography, which is a very expensive solution, was indicated at 45,000. Some parties said it's much more in their country. And reclamation units could be from $5,000 onwards, also again, depending on the capacity. Retrofitting existing hazardous waste facilities, such as the rotary kilns, which was mentioned this morning, can be a cost between $50,000 and $100,000. A new dedicated facility, like a small rotary kiln, $3 million. Commercial plasma arc facilities, $4.2 million. A few words on policies and programs. Both mandatory and voluntary LRM policies and programs are currently implemented in many parties already. Many lessons have been learned from the varying success of these policies and programs. It has been identified that policy enforcement is challenging due to the large volume of end users, distributors, and independent contractors that are involved. Effective LRM requires stakeholder support, particularly when developing reverse supply chain infrastructure and technician training. Voluntary actions, compliance, offset generation, incentivization, and corporate citizenship programs can also be very helpful. And the safe handling and transportation of refrigerants must also be considered, in particular when we are moving more to flammable refrigerants in the future. Article 5 parties, and especially low volume consuming parties, lack or have inadequate LRM infrastructure. And we are talking here again about leak detection equipment, recovery and recycling equipment, and the associated tools, the access to reclamation and destruction units, analysis laboratories, expertise, and logistics to effectively manage the reused refrigerants. While some larger industrial Article 5 parties may have more developed infrastructure, they often also require upgrades or replacements for their existing tools and equipment to improve LRM. And significant benefits could arise from Article 5 parties working together. It was also mentioned this morning, the regional cooperation to set up capital-intensive integrated reclamation and destruction infrastructure. LRM capacity building focuses on technician training programs. These are critical in changing the behavior from venting refrigerants during servicing and at end of life. And again, consideration of safety is here very important during the handling and the transport. Local infrastructure mentioned already, and you can see here a few pictures that illustrate what is needed. We also have a chapter that tries to estimate what are the ozone and climate benefits of LRM. You can see here that if you take a comparison between a pre-Kigali baseline, where the refrigerant transition measures are implemented before June 2018, together with some LRM measures before 2018, and you take that as a baseline, and then you add what if more parties would add more LRM measures. It was estimated that this could yield a difference, a cumulative difference between 2025 to 2050, up to 5 ODP kilotons and up to 39 gigatons CO2 equivalent. Of course, in reality, Kigali is there, so the actual result in your country could be different, but then further simulation will have to be done with more data, which was not possible in the time frame we had to make the report. So in conclusions, for the report, technologies were found to be available for LRM, but not accessible in all Article 5 parties. There are policy, economic, and accessibility obstacles and challenges associated with effective LRM. And it was also found that if you have a phase-out or phase-down regime that creates a shortage of refrigerant and leads to price increases, then refrigerant recovery may. However, if that's not the case, you will need other policy and economic measures to support LRM. Both mandatory and voluntary policies and programs were currently implemented in many parties already with varying levels of effectiveness. It was also found that establishing a data collection system by parties could inform their decision-making for optimal LRM strategies. And it was not possible in the time frame of the report to make a more deep cost-effectiveness analysis of LRM. LRM practices can be a key component of refrigerant emission reductions. I think that's also quite well known to you. It can achieve emission reductions beyond those from strictly Kigali compliance. It may be even the key tool for some parties to achieve Kigali compliance. And the TEEP will continue to follow these issues and its potential emission reduction opportunities. And with that, I thank you for your attention. And you will see here the group picture of the people who contributed to this report. And I would like to thank them once again for this. Thank you.
Thank you very much. So we now have 20 minutes for questions and discussion. Is there any? All right. First out of the gate. Do we have a roving mic or?
Thank you, Adam. Let's suppose that we don't do nothing. Forget about this. We bend everything. How much will be the cost compared with this? Because if I'm a person and look this, I don't want to invest anything because I don't know what will be the cost of doing nothing. Will be interesting to compare. If we don't do nothing, what will happen? For example, Dominican Republic, we don't do nothing. That reflects increase in temperature, many problems, more air conditioning, more energy consumption. If we compare this, we can say, okay, it's better to do something than not doing nothing. Thank you.
Thank you for the question. Before I give the answers, I would like to clarify that in the discussion, I will speak in my personal capacity. So please don't consider that this is the answer from TEEP, but I will try to do my best to answer your question. So on the cost effectiveness, actually, as I mentioned, we did not cover that in the report. My personal opinion is that this will depend also on the country situation. If we look to emission trading, for example, is it, I'm from Europe, is this 100 euro per ton CO2 equivalent saved? Is it more? Is it less? It's also evolving over time. So you will indeed have to evaluate what is your best investment for what kind of result you can achieve. So I think there is no single answer to your question, but it's certainly something that needs to be looked at. Yeah.
The back.
Hi, Heidi. Thank you very much for very comprehensive presentation. I'm just wondering, during the preparation of this report, TEEP had any opportunities to look back at the experience gain in terms of recovery, recycling, etc., and also destruction activities that were done before Kigali Amendment, because multilateral fund has spent more than $100 million just on recovery recycling. And it appears that there are a number of challenges which probably common to what we're going to pursue in the future, and what kind of lesson that we can learn from those experiences.
Thank you very much, Viraj. Indeed, in chapter 7, and it was my co-chair, Roberto Pecciotto, who worked on that chapter with the team, we have included some MLF experiences, including costs and benefits that were derived from LMF projects. So there are some examples given in the chapter. But I don't know them all by heart, but we can discuss maybe later on. But it's certainly in chapter 7 covered to some extent. We asked the MLF to give us also their expertise as a background. Thank you.
I'll take the front half of the room. You take the back half of the room. Let's be easier on us.
Hi, I would like to ask if there's any funding allocated for destruction facilities or anything like that from the MLF, since it's mentioned.
Yeah, again, in chapter 7, there is examples of potential funding, including for destruction. I think we mentioned the CDM, the joint program that Japan particularly has experience with. MLF was mentioned, and some few other possibilities are mentioned in the chapter. So there are examples given. Yes, thank you.
Other questions? I have a question. What is the next step?
Well, in October, there will be this workshop on LRM, where the task force members will probably also have some contribution, but many other parties will pitch in and share their experiences and thoughts. And then it's up to the parties to decide if they want the TEEP task force to make an update of the report or not. This I don't know yet. It will depend on what the parties request to the TEEP.
Thank you. No? We're in a post-lunch doldrum right now. Maybe we should stand up and do some jumping jacks. I have one more question. Maybe it'll warm up the rest of the people. So in the modeling that you did, right, you were using pre-Kigali baselines. You were saying it was because of a lack of data and time. Is the data available to do Kigali analysis by country?
By country, probably yes. It was Palaf in particular who has worked on this gains model, and he's doing it for several countries. So probably there is a potential to do more, but within the time frame of the report, we couldn't.
I understand. Thank you. That wasn't exciting enough of a question. Wait, sorry. Over Makoto.
Thanks. Thanks, Hilde-san, for your excellent presentation. One question, very coming out of my curiosity. I think this report is basically for the purpose of kind of like giving a background information for the negotiation in the forthcoming COP36, and also XCON. But apart from those negotiations, because this report has been prepared in a very frantic and very short time period, are there any potential from your professional perspective, not TEEP representative, but from your professional perspective, are there any potential areas that you may suggest that we should dig in further? Because I think there are lots of uncertainties, or because of the time constraints, what I think what the discussion was had to be done in a very short time, right? But if there is more time for deliberation, perhaps there could be more accurate understanding or something. I mean, this is just for the curiosity. Question.
Yeah, thank you for the question. Again, my personal opinion, I think more investigation is necessary on how the financial flows should be going to make LRM effectively work. There are so many parties involved, and you need to make sure that you have a win-win situation. Otherwise, it will not be effective. So what has the end user to gain? What does the government have to gain? What can be benefit for the industry? This needs very careful consideration. We have seen in some countries what worked and what didn't work, and we need to take those lessons further. I can give you an example of the European Union again. We have an e-waste directive already for many years. So if I buy by collective programs, and they use that money to treat the old units that are coming back. It turns out that this is not working very well. And the reason, to my opinion, is that the end user has nothing to gain. And then if you see to other industries like mobile phones, for example, if I buy a new mobile phone and I bring back my old one, I get a discount on the new. That's motivating. Yeah. So we also have to rethink how the money flows and what can be the benefit for everybody that is involved. Otherwise, it will not work. I think that deserves a bit more discussion. But whether that's in the task force or outside the task force, I cannot decide on that.
You mentioned the possibility of sort of regional consortia of multiple parties potentially cooperating together to sort of achieve either reclamation or destruction. How do you think about Basel's movement of controlled substances, and should that be a focus of some people in this room or others moving forward?
Indeed, you're correct. We even mentioned it in the report that the Basel Convention could be a barrier. It doesn't have to be. It depends on how you handle it. And for that reason, I think in the workshop, some people from the Basel Convention may be there to give some further explanation to the parties. That's at least what I heard would be on the program. But indeed, it's a challenge to bring across recovered refrigerant over the borders. What we also learned is that whether you define recovered refrigerant as being waste or not waste is quite essential. And we have again a case in Europe where Hungary changed the definition. So before, any recovered refrigerant was automatically considered waste. They have changed that now. And if the purpose is to reuse the refrigerant, it's not waste. If the purpose is, or the destination is destruction, then it is waste. So that's a whole different concept. It makes a major difference for the transport and the handling of the refrigerant. So that's an example of something that needs to be maybe considered also by other parties.
Thank you. I think what you just mentioned is similar to what Vietnam has just done with their regulation. Basically, if you recover and send it to reprocessing facility, that would not be covered under the hazardous waste regulation. So only when it's destined for final destruction, then that would be considered. I have one more technical question. And this question is coming from non-technical person. Basically, I couldn't understand why when we recover recycle refrigerant from mobile air conditioners, we can put it back or we can use in other MAC system. But for air conditioning and refrigeration, we will have to ensure that it meets certain standard before we use it. Why there's such a difference? And if there's a real difference, why can't we redesign the air conditioning and refrigeration system that's similar to mobile air conditioner to promote the use of recover or recycle materials?
Thank you. This has been discussed under the ISO standard 5149, I think. And it has actually a flow chart for any rack HP equipment, whether it's mobile or stationary, doesn't matter, on in which case recovered refrigerant can be directly reused even without going through recycling. When do you need to recycle and where can you then use the recycled refrigerant, and in which cases you really have to go for reclamation. It has to do with where does it refrigerant come from? Where are you going to reuse it? Does it pass an acidity test, a moisture test, yes or no? So there's a whole flow chart. We have it also in the report that helps you to determine what can be used with recovered refrigerant and where. And it doesn't have to be different. In the case of the mobile, 134A is a single component refrigerant. If you use 410A, that's a blend, but it's a nearly azeotropic blend. If it's R32, it's a single component refrigerant. So again, it makes a whole difference on how easy you can reuse the refrigerant or not. Yeah.
Hello, Halde. Thanks for wonderful presentation. I have two questions in particular. The long discussed issue of training and certification of servicing technicians, which has been a barrier for a very, very long time during CFC phase out regimes at CFC. And again, this will be existing for the HFC phase down as well. So in your personal capacity, do you think moving forward, there will be more investment from more consideration from MLF or the Montreal Protocol Committee on training and certification, particularly in the Article 5 countries. Second question is on the recovery machines and the recovery cylinders. Has it been discussed in the report, or has it been considered that there is further need to for research and development for smaller recovery machines, which can be easily taken by servicing technicians in their motor vehicles in Article 5 countries mostly, because the large size machines plus the recovery cylinders plus the whole toolkit for servicing is quite difficult to carry. So are these two aspects touched in the report, and what do you think about it? Thank you.
I'll start with your second question. Indeed, it has been mentioned as a challenge, especially if technicians go with their motorcycles to the site. And I think in the report there is mentioned the case of India, where even small cylinders were not allowed, but then it's difficult to carry them. So that is mentioned as a barrier that needs to be overcome. And for whether the multilateral fund will focus more on training or not, I cannot answer that. I think multilateral fund discussions should happen. But in generally, I can say training and certification will remain important, whatever refrigerant you're using, even if it's not an HFC. So I think that attention is growing everywhere in the world. But it has also been identified as a challenge that you need to reach many more people. It's not sufficient to train a few people and forget about the rest of the country. So that was also identified as a challenge. It really needs to be more widespread. Thank you.
We have time for one more question.
I don't know if any questions from the
Yep.
online.
So far, no.
Okay, good.
Sorry, I missed some of your presentation, but I'm from UNIDO. We are implementing MRF project. We have several reclamation centers being set up. We have found not a recovery machine, but a recycling machine, but mobile reclamation machine providers. I wonder if you evaluated in the report, or like a comparison between bringing reclamation machines to the site or the reclamation machine fixed version. Have you ever evaluated that?
Well, in the presentation, I mentioned that reclamation facilities are typically more fixed and centralized, whereas recycling is more local and more mobile. But with that, it could be that there is also mobile reclamation technology available. And to be honest, I need to check the report again, whether you mentioned it or not. Technologies are also evolving, but let me check for you and come back to you.
Thank you very much. Please join me in thanking our distinguished speaker. Thank you, Hilda, for that wonderful presentation and discussion. So we're now going to move to session 4.2 today. There are three. We're going to begin with three 15-minute presentations, followed by an interactive. I'm not sure we should call it a game necessarily, but an interactive activity that's going to take place in two parts today. So stick with us. If you feel like your blood pressure is dropping off, you're going to have the opportunity to get up and move around here shortly. So don't fall asleep on us yet, particularly because I think these are going to be very interesting presentations here. So as I said, three 15-minute presentations. The first is on leakage prevention technologies. And so I would like to invite Mr. Kozo Sakaguchi. I apologize if I butcher any of your names. I'm trying here. Mr. And is it just you, or are you joined by your colleague? Just you. Okay. So please, the stage is yours.
Okay, My name is Kozo Sakaguchi of E&E Solutions. I will be presenting energy saving by refrigerant leakage prevention technology using ultrasonic detection system and IoT, and with Mr. Namba, President of Namba Corporation, Namba 社長。はい。Firstly, I'd like to thank you for the great opportunity. Let me start the background of the presentation. E&E Solution, EES, has been involved in a series of projects related to fluorocarbon refrigerant management under the Ministry of the Environment, Japan, MOE. Particularly in Thailand, EES has participated in the destruction demonstration project and in the JCM project for fluorocarbon destruction. Moreover, Namba and ES carried out the test for refrigerant leak monitoring in Malaysia. Originally, Japan has promoted the development of leakage prevention technology because we found out that refrigerant leakage is frequent during the use of the refrigeration and air conditioning equipment. Throughout previous project, we have been introducing Namba's fluorocarbon refrigerant leak detection system, Fluorocarbon, and have received many interest from people, including Thailand. We believe that it is important to help those people understand how Fluorocarbon works well by showing the actual case study. Therefore, installation tests have been undertaken in cooperation with related stakeholders. From 2023, as part of MOE project, Namba and EES are collaborating with Ichinen Tasco and Sanyo SMI of Thailand to conduct leak monitoring demonstration in Thailand. Let me introduce about EES. We are an environmental consulting company located in Tokyo, and previous provide various environmental and energy consulting services. This is about Namba. Namba is a company to design, install, and maintain refrigeration and air conditioning equipment. Namba's mission is to prevent global warming. And in 2012, the company released the detection system of fluorocarbon refrigerant and Fluorocarbon. The purpose of Fluorocarbon is to detect refrigerant leak earlier than the temperature sensor does. The photo on the left shows the Fluorocarbon installed in a refrigeration, and right photo shows the Namba was awarded the Ministers of the Environment Prize in 2020. First, I will explain the status of fluorocarbon refrigerant in refrigeration unit. This oval-shaped image shows the receiver tank stocked and with liquid refrigerant. The refrigerant repeatedly changes its state into gas and liquid in the refrigeration cycle. Because this cycle is sealed and refrigerant amount will not be reduced for decades if there is no leak. However, leakage is often caused due to collision and age-related deterioration of the equipment. Usually, a temperature alarm detects leakage, but at that time, 50 to 80% of refrigerant have already leaked. In this condition, the compressor is operating continuously with increase of power consumption and the high risk of its failure. On the other hand, Freon keeper can find a refrigerant leak at 10% leak at 10% before impact on the compressor condition. This slide explains how the Freon keeper detects refrigerant leaks. When the amount of fluorocarbon refrigerant is reduced, refrigerant gas cannot be fully turned into liquid status due to poor condensation in the cycle. This remaining gas is called flash gas. This photo shows us a sight glass attached to the refrigerator, which is an inspection window to visually check the flash gas. Picture A is Picture A is when the optimal amount of fluorocarbon refrigerant is filled. No flash gas is observed because fully liquid refrigerant is passing through the sight glass. Photo B is when a small leakage is occurred. Thus, a drop of bubble can be seen. Finally, the picture C is when more than 50% refrigerant is leaking. You can see the many of bubble formings. Freon keeper can monitor these bubbles 24 hours using ultrasonic waves. The sight glass is used when visual inspection. Service technician can suspect the leakage visually only if it is a condition C. However, Freon keeper can detect the leakage that even service technician cannot find by the visual inspection. This data of a relationship between refrigerant leakage and increased power consumption. The data was observed by NAMBA as a subcontractor for research project conducted by MOE. The graph shows that power consumption increased by 80% when refrigerant leaks 50% from the proper amount. When refrigerant leak occurs, refrigeration capacity is reduced and compressor operating rate is increased, resulting in increased power consumption. Moreover, since the temperature alarm detects from 50% leakage, the refrigeration system will continue its operation with high power consumption. Freon keeper has three benefits. The first one is cost reduction. Freon keeper can significantly reduce power consumption and the recharge cost of refrigerant. The second is to reduce fluorocarbon refrigerant leakage. This means Freon keeper contributes to mitigate the global warming by preventing the emission of fluorocarbons, which have a high global warming potential. The third is stable operation of equipment by detection refrigerant leakage before the equipment stops cooling. Loss of inventory and sales opportunity can be prevented. Freon keeper turns refrigeration equipment into IoT. Various sensors are installed in the equipment. and operational cost, operational data is sent to the server using Wi-Fi. Data from the server can be checked on PCs around the world, allowing to centralize management of equipment at each location. Freon Keeper can determine refrigerant leakage based, okay, sorry. In 2018, Number carried out the installation test of Freon Keeper in Malaysia with the support of NEDO of Japan. So I'd like to introduce the test result briefly. In this case, Freon Keeper was installed on chiller system for air conditioning in a shopping mall in Malaysia. 3 chillers were installed and 2 of them, number 1 and number 3, were in operation. Each chiller had 3 compressors. Here is a monitoring result of the number 3 chillers. First, please see the upper graph, which is before the refrigerant was discharged. The graph shows the daily status of flash gas and the electricity consumption. The blue line shows the amount of electricity which had quickly increased from the bottom to the top. This increasing point shows how the chiller for air conditioning was turned on when the shopping malls opened for business. The green line shows the flash gas, which also rapidly increased as soon as the power is turned on. This condition can be identified as a very serious leakage of refrigerant. Because normally, if the correct amount of refrigerant is charged, no flash gas is generated, which the green line is stable at the bottom of the graph. Therefore, we ask the maintenance contractor to repair the leak point and recharge refrigerant. The results shown in the lower graph. Even though the power is turned on, the green line became running around the bottom. In data right side, the flash gas dropped from 80% to 40%. And the water temperature dropped from 50 degrees Celsius to 12 degrees too. The discharge and sanction temperature were also largely down, clearly indicating that the discharge of refrigerant improved its cooling capacity. However, the amount of electricity increased from 2030 kilowatt-hour to 2130. This increase is estimated due to the increase in cooling capacity. Also, the flash gas generation rate was not zero, which means the amount of the refrigerant was not enough. Therefore, it was decided to take second measures to reduce the number of operated compressors from 3 to 2. The result is shown in lower graph. And the flash gas rate has further settled down. In data, the flash gas generation rate was reduced from 40% to 4%. And the electricity consumption was lowered from 2,130 to 1,300 kilowatt hour. Moreover, the water temperature increased only 1 degree. Compared to before the installation of the Freon Keeper, the capacity has increased and amount of electricity has decreased. In addition, the amount of refrigerant was close to adequate by operating two compressors as a result. Here is a summary graph of the flash gas generation rate for 3.5 months installation. First, the red arrow indicates that the flash gas began to reduce. When refrigerant was recharged and the blue arrow indicates that additional reduction when the number of compressor was controlled as second measures. Here's a graph of electricity consumption for the same period. A red box indicates the result of second measures, which shows 38% reduction in electricity. In conclusion, the water temperature is in number 3 chiller, which measures were taken, fell from 15.5 degrees to 30 degrees. Even in number 1, which no measure were taken, the water temperature dropped from 15.7 degrees to 13.7 degrees consequently. As a result, the amount of electricity used in number 3 chiller was reduced by 38%. Next, I am introducing the demonstration test in Thailand with the extensive cooperation of Sanyo SMI, which is an installation and maintenance company in Thailand. We have installed Freon Keeper in the stores of Lotus, a local supermarket. These photos show how Freon Keeper installed in a refrigerator. Various sensors are attached, such as bases, Wi-Fi routers, and ultrasonic sensors on a refrigeration unit. This shows when the Japanese embassy in Thailand and the MOE's Fluorocarbon Control Policy Office visited in the installation site. The executives of the equipment users and the maintenance company also visited to the site. And they show their high level of interest, and they showed a high level of interest of in Freon Keepers. This is a part of result from the test in Thailand. The green line is a flash gas generation, which clearly shows that the refrigerant was filled twice on November 2nd and November 23rd. After the second filling, this rate has settled, but we can see a gradual increase clearly indicating that there are still some leaking. Unfortunately, the test period was not enough long, so we can't get very good data this time. However, The users and maintenance companies have been highly appreciated how Fluorocarbon can effectively provide data on the operating conditions and malfunction of the refrigeration unit. Moreover, the test reveals the high level of Sanyo SMI's technical capabilities. In summary, first of all, the increased electricity due to fluorocarbon refrigerant leakage is not well recognized, but its reduction effect of energy is very significant. Secondly, it is too late to repair the equipment after it has stopped cooling. Maintaining the proper amount of refrigerant can extend the life of the equipment and increase instead of being messed up by unexpected repairs. Repairs is easily scheduled and prevent loss of inventory losses and selling opportunities. Finally, from the viewpoint of climate change, preventing leakage of fluorocarbon refrigerant during use of equipment should be seriously addressed, taking into account its significant reduction effect. Okay. Thank you very much.
That was fantastic. Thank you very much. Very interesting presentation. Great country examples. That was hopefully we'll have a chance to have a little bit of discussion about this at the conclusion of the presentations. But without further ado, I would like to invite up Mr. Akira Mizuhara and Mr. Hirotaka Hata, or one of you, whichever one's giving the presentation, on technologies for reclamation of used refrigerants. Thank you very much.
Nice to meet you, everyone. My name is Hata from MZ Company Limited in Japanese company. I'm going to talk about technologies reclamation of used refrigerants. The first topic is which refrigerant is suitable for reclamation. Refrigerant recoveries from cooling equipment can be reclaimed by achieving the same quality as new refrigerant and refilling other refrigerant, air conditioner, and other equipment. Oil and moisture mixed in refrigerant are removed after reclaiming. Different of refrigerant are difficult to separate and extract, and if significant amount is mixed, the refrigerant must be discarded. Therefore, in order to reclaim refrigerant, different types of refrigerant must not be mixed. Air can be removed to some extent during the reclamation process, but it is necessary to avoid mixing air with refrigerant as much as possible. The second topic is what to do before recovering refrigerant. A very important point. Before recovering the refrigerant, the recovery cylinder must be sufficiently vacuumed. It is also necessary to self-cleaning the recovery machine and completely discharge the refrigerant remaining in the condenser inside the recovery machine Also, this is usually done when the previous recovery operation is completed. In addition, if the recovery machine uh, and manifold and charge hose use not dedicated to the refrigerant type. It is necessary to dry running the recovery machine for several minutes to discharge the refrigerant remaining in them. This is recovery cylinder. Maximum weight is 20 kilogram, equipped with a float sensor for safe recovery. The third topic is result of verifying the effect of self-cleaning and dry running of recovery machine. In order to verify the effect of dry running of the recovery machine, the following two cases were investigated. One case where R410A was collected without dry running after collecting R22. And another case where R410A was recovered after 5 minutes of dry running, and we checked the purity of each R410A. As a result, the purity of R410A recovered without dry running was 19.39%, making it suitable for reclaiming. The graph on the left shows the result. On the other hand, the purity of R410A recovered after dry running was 19.93%, which is suitable for reclaiming. The graph on the right shows the result. The last topic is explanation of how to reclaim refrigerant. Introduction is the method of reclaiming refrigerant the MZ group is doing in Japan. Refrigerant for reclamation is recovery in a cylinder of about 120 liters and reclaim. First of all, refrigerant are liquid in the cylinder and evaporated when heated. Next, the oil mist contained in the gas is removed by the oil absorbent. Then moisture and acid are removed by moisture absorbent and acid absorbent. Last, the refrigerant gas from which impurities have been removed is cool and liquefied to become recurrent refrigerant. Detailed information is a display. So please come to take a look. Thank you very much.
Thank you very much. That's fantastic. We are right on time, which is wonderful. So let's jump over to our third presentation in this group. I'd like to invite Ms. Sutida from DOA Ecosystem EE Solutions to talk about destruction technology combined with hazardous waste.
My name is Suthida from DOA Ecosystem, and actually I represent Waste Management Siam in Thailand as well. So today I would like to explain about the destruction technology that combine with the hazardous waste in Thailand that we are running now. And before that, let me not move. Okay,ค่ะ Okay. So first, let me introduce my parents' company in Japan. Actually, both Waste Management Siam, DOA Ecosystem, and also E&E Solution, we are in the umbrella of DOA Holding Groups in Japan, which is established more than 100 years ago in year 1884 in Japan. And then the sale for last year is about 4.98 billions for the end of last year, with over 10,000 employees all over the world, because we have like more than 100 plants and office all over the world. And also for DOA Holding Groups, we have like 5 core business, which is the first one is the DOA Ecosystem, which is our company, Waste Management Siam, and also E&E Solution within this umbrella of the DOA Ecosystem. DOA Ecosystem is the environmental management and recycling company. And also we have the DOA Metal and Mining, we have the DOA Electronics, DOA Metal Tech, and also DOA Thermotech. And in Thailand here, for under the DOA Ecosystem, we have like Waste Management Siam, we have BKK, which is the destruction facility in Thailand. We have SBEC, another company, and we also run by Waste Management Siam, which is the operating company in Thailand. So for DOA groups, we have a philosophy to run business, which is like the sustainable business model. As you see that in the previous slide, I explained that we have 5 core business, and that 5 core business is supporting each other. We have like the metal production from our mining and smelting company, so we can produce gold, metal, some like precious metal and rare metal that we can produce, and then we send it to our another group of the company that can produce the part for the semiconductor, the part that can be value added material, and then we send that material to the consumer unit, like we can produce to be the PCB for the mobile unit. We produce some material that can use for the PV panel, for the car, for the automobile. And then after that, for the end of life, we also have our company, DOA Ecosystem, that can do like the recycling, and we have the waste disposal for the thing that cannot be recycled anymore. And then we can have that soil remediation business as well. As I say that for our company, we have like the global environmental mining and recycling business. We have like more than 80 countries all over the world for both the DOA Ecosystem and also E&E Solutions. And in Thailand, I think Thailand have like much more than other countries. Some other countries we have like only 1 facilities, but in Thailand we have like 4 companies, and we have like 5 facilities in Thailand. For DOA, we have DOA Ecosystem, we have like 4
four core business. We have recycling, we have waste management, we have soil remediation, and we also have run our own fleet, domestic logistic company. So we can control our quality of transportation that we can serve the customer the best. Here, let me introduce the Thailand operation under the waste management Siam facility in Thailand. We have like the first one. Here we see the Bangpo environmental complex. This is the incineration that can burn both hazardous and non-hazardous for solid, for liquid, and also for gas waste. And we also produce the steam that can sell to other factory nearby, and we can also produce the electricity to be like the steam turbine generation as well. And we have another incineration, the furnace that we install later for the pre-treatment for the battery before we segregate the metal and precious metal, and we can send back to Japan for the recycling. That for the lithium battery and the nickel metal hydride battery for the hybrid, and also the EV vehicle as well. And we have the SBEC. SBEC here is the landfill. We have a secure landfill that can treat both hazardous. For the landfill, we treat only non-hazardous, but we also can treat hazardous for the alternative raw material for the cement clean. And we have the wastewater treatment plant, and we also do the WEE dismantling project in our facility in Chonburi. And we also have the transfer station all over Thailand, because our customer is like located from the north to the south of Thailand. And because of that, we have to run our own transportation to make sure that we can control the quality of the service to our customers. Okay, here is the destruction facility in Thailand. This is at the Bangpo Environmental Complex, which is just in Samut Prakan province in the eastern part of Bangkok, just the connecting province. For the Bangpo Environmental Complex, we can treat the solid waste for 150 tons per day and liquid waste for 123 tons per day. And also we can treat gas waste. Gas waste, which is like mostly that we treat right now is the refrigerant. We can treat for 0.6% of the total capacity of the solid waste. It means that we can treat for 900 kgs of the refrigerant per day at this moment. So for the technology that we use the main furnace, we use the fluidized bed technology, because we can save the energy on that, and we feed the refrigerant and the gas waste into the main furnace, into this, together with the hazardous and non-hazardous waste. And then we have the full gas treatment system. And at the end of the pipe by the stack, we also have the 24 hours, the monitoring system that connect with the Industrial Estate Authority of Thailand, so they can monitor our full gas treatment system. And for in Thailand, I can say that BKK is only the one and only facility that can treat gas waste, that can check the destruction removal efficiency, that before we get the permit, we have to do the trial. And for the trial, we have to treat that refrigerant to be like disappear for more than 99.99% on that. So we are one and only that can make sure that every customer that send their refrigerant to us, we can have the certification, and we can check the quality of the gas treatment, that we can treat that 99.99%. And this is the way that we do. We have like both the factory, we can say like factory and non-factory. Factory, actually most of the factory that have the refrigerant is our customer already. And then we have the recovery. For the recovery, we did not do ourselves. We have our partner that do the recovery at the facility, at the factory, our customer, and then we have our own fleet transportation to bring that gas waste to our site, and we do the destruction here. at BPEC. And currently we can treat more than like 100 tons per year from last year. And apart from that, we also have some other activities. We do the recovery technique demonstration. We do some PR activities because we would like to bring awareness to our society for the factory and also non-factory as well, that how important to treat that freon, to treat that refrigerant properly. And we also have some like the destruction of the custom department in Thailand sees the illegal importing refrigerant in Thailand and then kept it at the custom department for more than 10 years. It's about like more than 100 tons. And then we just dispose it. Early this year, we just like finished that. So this is the problem and the obstacle in Thailand. Actually, in Thailand, for factory, we may have like the waste code for the hazardous substance, which is like the refrigerant is in here. But for the non-factory, there is like no control. And even for the factory that has control that there is a waste code, but there is no specific guideline on how to do. It's just like it's controlled, but there is no specific regulation on that. And there are like there is no inventory record. It's like nobody knows, like the data is just like spreading all over, but it's like no one that will be like the collecting person. We have like the ozone department. We have many departments, but the data is not collecting. Yeah, I think I already present that for the factory. Most of the factory is already our customer, and this is controlled by the Ministry of Industry because there is already waste code. But for the non-factory, there is like two department, two ministry that taking care of that is the Ministry of Public Health and Ministry of Environment, Natural Resources. And now they try to put the refrigerant in the system, but there is like still on the working process. There is like no solid plan yet. Like we working on this for like many years since we get supporting by MOEJ, by E&E Solution, that how we going to develop the management of the CFC and the refrigerant in Thailand. And we work very hard, like jump into one department, one ministry to another ministry. We try to get the collaboration between government section, and we hope that sooner everything going to be like happen, and Thailand should have some solid plan to manage the refrigerant. And apart from that, we also have some activities with the government, like the Pollution Control Department, with the Ministry of Environment and Natural Resources. We do some WEEE collecting, dismantling, and also recycling. And we know that for that, WEEE is mean that air conditioning as well. And there are some refrigerant that still kept inside that. Also, we also collect that, and we propose the time frame and the framework of the e-waste management flow that we present to the government. And I think I work in this business for 20 years, and we talk about WEEE for that 20 years, and that not happened yet. And hopefully within this government, this public, the WEEE Act should be out for people to be utilize it. Apart from that, I heard from early that we talk about the ELV as well, end of life vehicle. We also, as you know, that we try to collaboration with many sector. One of the sector is the car company, mobile company, the automobile company. We collaborate with the Toyota Motor Groups. We collaborate on the ELV management. Toyota also has their own company, the group company that do the dismantling, and that in the ELV there are some refrigerant that left in the air condition, and also the liquid hazardous waste. So after the dismantling at the facility, the liquid waste we send to our facility in Chonburi, and the freon, the gas waste is sent to BPEC for the destruction. But until now, we work on that since year 2017 for the ELV, but it's still not happened yet. We still have to work on it more and more. And this is the example of the project that we did with the ECAT, Electricity Generation Authority of Thailand. We do the model project with the ECAT and also the Home Pro. Home Pro is the department store that sell the home appliance and also the WEE. So we have the process framework is that they launch for 375 machine for the set of the refrigerant of the air conditioner. So they announced that if you have the old air conditioner, you can register in the system that you would like to trade it. So it'll be like old to new. And then when you register and then they accept that, they will send this company, Daikin will have the FC recovery team. If they accept that, you buy the new air conditioner at some of the Home Pro department, and then this team will come to your home, and then they will recover the FC, the refrigerant in your old air conditioner, and then they will install the new one. And for that old one, they will come back to their warehouse, and for the air conditioner itself, is sent to our facility in Esbeck for the dismantling, and for the refrigerant is sent to the destruction at our facility in BPEC. So this is like the closed loop of that, and this project is already in, and I'm not sure whether they're going to, but I heard that there are like some department store like the Power Buy is also try to create this kind of activities as well. This is the one that I talking about, that we cooperate with the custom department because they have like more than 136 tons of the is more than 10,000 cylinders that live in their warehouse all over Thailand, in southern part, in the like at the border of Thailand, that illegal importing, and then we help them to collect that, and then we burn it at our facility in Samut Prakan, which is BPEC, and we have this is the DG of the Department of Industrial Work. He's the governor of the Industrial Authority of Thailand, and we have the some of our MOEJ and also the Embassy of Japan in Thailand that we witness that we have to be aware that we get the funding from overseas to help pay for the destruction, but I don't know, like for other thing, other company that still have that, I don't know how they're going to manage it. And I heard that the custom department still have like some other type of the refrigerant that located in other border, in other office all over Thailand. So we try to collaborate with them again, that if they have more, we are happy to help, and then we can burn it instead of, because sometimes when we collect it at the warehouse, it's like empty because it's already leaked. So we would like to make sure that if they have it, just let us know, and then we can collect it instead of let it leak to the atmosphere. Yeah. So this is like what I would like to is to emphasize that the refrigerant and the gas waste is very important for the proper management. And I can say that here we are only one and only in Thailand that can destruct it in a very proper way. But unfortunately, we have only 0.6% of our capacity, which is only like 900 kgs per day that we can treat. But hopefully we can treat more in the future, and if we can like get some more business, and we can amend our environmental impact assessment for the facility. So hope that we can do better for a better Thailand and better world. Thank you.
Thank you. Thank you so much. So we have time now for, I think, maybe 2 questions before we move to the next session. For any of the speakers?
For the last speaker, I have a question on your slide number 12. Not quite sure exactly what you meant. First, you're saying that the HFC is regulated by Ministry of Industry, and fluorocarbons are regulated as hazardous waste code. However, no specific regulation for fluorocarbons. But I understand that under the Factory Act,
Yes.
any unused refrigerant within the factory would have to be treated properly, which means it has to be properly destroyed. So I don't know what aspect that you are saying that there's no specific control. And in the bottom, you said there's still no direct refrigerant control and regulation for each sector. You're talking about the end of life, or you're talking about the general? Because in general, there's a control in terms of import, and also there's a ban on certain sector for certain kind of chemicals, including CFC, CFCs. So could you elaborate on that?
Yes, for that, as you already mentioned, thank you for the questions. As you already mentioned that the gas waste is already controlled by the DIW to be like the hazardous substance, but it just said that to be destroyed properly. But what we concern is that to destroy properly, it just mean that burn it. But there is like no the monitoring, like for our facility, we monitor that. We have to make sure that we can destroy like the destruction recovery efficiency is like more than 99.99%. And we have the measurement at the stack. We have like the measurement to collect the gas that going to out of the stack, and we send it to the laboratory. At the gas is already like destroyed. It have to be left only like less than 0.1% of the gas waste left.
Act. So it covered by different act. So you're telling me that you can set up the destruction facility in Thailand
Yes.
without worrying about emission? I don't think that is correct. So maybe you want more than the regulations are required.
Yes.
But there is control, but maybe not as much as you would like.
Yes.
So it would be
It's
made
not
very
specific,
useful
yeah.
if you could highlight which part that you want to see them strengthen.
Yes, sure. We are like working with the DIW as well, like how to make the guideline of the destruction and how to monitor the destruction efficiency to make sure that it's be like destroyed as much as possible.
Thank you.
Thank you, Nathan. A question for you, very simple. I'm a little bit confused. The technology that you are using for the destruction is cement kiln or what?
Waste incineration using fluidized bed technology.
Okay. No particular technology.
Yeah, it's the fluidized bed technology. This is we starting our facility by the waste management. So we burn hazardous, non-hazardous since we first start like 20 years ago. And then after we get the collaboration from MOEJ and also E&E solution. So we try to make like how we can burn, because in Japan, they can burn that refrigerant together with the incineration, the normal incineration. So we adopt that to be in Thailand. So we burn it in like together with our normal waste, but we have to control the feeding, the incoming only for like 0.6% of the total capacity of that capacity of the solid waste.
Okay.
So, but in Japan, it's like 3%, but now we adopt only like 0.6% of the total capacity.
Okay.
Yeah, we burn together with the general waste, other waste.
Okay, and a question for Namba, Mr. Koso. Where is Mr. Koso? I don't know. Okay. Are you using the mean time for, I already forget this. Mean time between failures in the analysis? Because I look, because this is used in other fields. Sorry, this is used in other field in meantime between failures. Are you using this? No.
Mean time between failures? No? The average time, the mean time between failures, are using that? In your analysis? No? I mean, if not, yeah, okay. Sorry. Okay, thank you. Well, there'll be a coffee break after the next session, so maybe you guys can come together and discuss that. But thank you very much for everyone, and I apologize we don't have time for more questions. Those were three very interesting presentations with some excellent case studies and examples from the real world. I think I took a lot away from it. Without further ado, I'd like to hand it over to my partner in crime here, Makoto, to discuss the next exciting interactive session.
Okay, thank you very much for the facilitation, Nathan. And also, we're jumping into the group discussion, but we're going to have give you a guidance. Can you show the slide, please? You see flip chart here, and we're going to play with this. And you have a refrigerant cup. Inside, you have refrigerants. So don't throw it. You have to collect and recover or destroy, right? Okay, please.
Okay. In this group discussion, we are going to unpack the relay works of life cycle refrigerant management. Let's exchange the idea and write them down to the worksheet directly. Here we prepared bowls representing using refrigerant and a capsule cylinder and the basic flow of life cycle refrigerant management on the sheet on a flipboard. And please imagine necessary technology, human resources such as technical expert, technical standards, laws, and regulation. We'll have a 2-session time for this work. First, let us focus on the technical aspect in this session. And the last session today, 433, and we will take up the legal and institutional aspect, economic aspect of life cycle refrigerant management. By the end of the discussion, we'll realize the specific kind of work and how this work should be realized in a combination, which are necessary for us to achieve the life cycle management. Who will transport the refrigerant? Who will carry the cost? And what kind of license and regulation are needed? Where or how should the amount of leaks refrigerant be measured? Now we have a 5 table, and I want to divide it 5 group and combine the 2 table into 1 team. And please use your pen and write your idea directly into the worksheet for about 15 minutes. And today, we are inviting some specialists of our LRM, and I would like to introduce Miss Amy from Malaysia and Miss Nathan from Miss Nathan from CCAC, and Mr. Sakaguchi from E&E Solution, and Mr. Yamanaka from Daikin, and Mr. Ashish from Gemba Next. Please be facilitated to this discussion. And after discussion, please choose 1 or 2 persons from your group to make a presentation, and presenter would briefly explain their ideas in a worksheet. Okay, let us start our discussion.
Just to follow up on, so you already have witnessed a very interesting interaction. For example, Hilde-san mentioned about the amendment of the legal requirements for shipping in Hungary, and that was actually corresponded by Viraj comment in Vietnam. So that now we are familiar with the concept of life cycle refrigerant management. It's kind of like a relay of different works, and then relay works of different stakeholders. In general, we understand, but when you go to the reality, for example, as questioned by Viraj and also responded by my colleague from DOA, BKK, well, there needs to be specific rules and regulations or specific arrangement for the quality check. What kind of technical standard or specification are necessary? We are actually working in this in Vietnam. They have nice legal framework, but still it says like sometimes like the law says the refrigerant reclaimers should do according to SAM standard, but we're missing this SAM standard thing. So that we are going to dive into the reality of the life practice of life cycle refrigerant management. And then what I recommend is that for of course we have diverse situation depending on countries and also organization, but you can actually share your experience and what are existent already in your country, for example. What are available, what's not available, and what can be actually, I wouldn't say copied, but actually you can get do cherry picking from different countries. Like you heard for a nice presentation from different countries. So I think this is something good for you to learn in the on the ground practice. And here you have refrigerant cup, and you have inside this. Oh, sorry, why I'm actually releasing with this refrigerant so that you can actually work step by step, and then please write down what are available or what are necessary, who is doing what. And then for the first 15 minutes, we focus on technology side. And then after this, we're going to, in the next session, we're going to listen to Japanese legal framework. And also we're also demonstrating a tracking of refrigerants on transportation shipping. So after that, we're going to come back to the discussion. But for the first 15 minutes, please focus on what are available technologies and what are necessary arrangements for those technologies to be applied or implemented. So you can write down memos to the flip chart. I hope our facilitators like Miki-san, Yamanaka-san, and also Nathan and others you can actually boost the discussion. Okay, so now Sayuri-san is going to announce the grouping.
Yes. So from one end, fifth table and number 2 table, please move to this flipboard next to the fifth table, and number 3 and 6 table and 5 and 4 table, please gather and discuss, and 7 and 8 and 9 and 10, please.
So here, like a table, these 2 tables, people, you get together in this around this flip chart. I think Nathan and Yamanaka-san, you need to split into 2 different groups, right? Yeah. And table 3 and 6, so you guys are together. And table 5 and 4, yeah, could you get together at that side? And 7 and 8, okay, on that side. And 9 and 10, you come to, yeah, this place. All right, please enjoy. Okay. Okay, good. How was the discussion? How's the discussion? Well, at this point of time, well, people are in confusion or like we're not yet ready to complete, but we still have time. But before that, well, I just want to thank Nathan for facilitating in the previous session. Thank you very much, Nathan. Yes. Okay. Okay. Now, while we are not yet finished with the group work, we are going to have another part of the life cycle refrigerant management conversation, which is about the legal and policy aspects. And today we have Dr. Hidemoto Miyake. He is from the Office of Fluorocarbon Life Cycle, Fluorocarbons Control Policy of the Ministry of the Environment, Japan, and he is actually dedicated to the legal implementation of the Japanese law on life cycle refrigerant management. So that he's going to introduce what are the key points of the Japanese legal framework, and well, maybe we can learn a lot from our experience. So with this, I would like to invite Miyake-san to the podium. Yes.
Good afternoon. I'm Hidetomo Miyake from Ministry of the Environment, Japan. I'm honored to talk about Japan's HFC emissions control policies. Slide 1. Back in 1988, when the Montreal Protocol, Japan's first fluorocarbon consumption control policy was enacted to protect the ozone layer. To control fluorocarbon emissions, we enacted the Fluorocarbon Recovery and Destruction Act in 2001 here, and then renamed Fluorocarbon Emission Control Act and strengthened. Also, recycle residential and car air conditions. We have the Act of Recycle of Home Appliance and the Act on Recycle and End Life Automobiles. This just shows Japan's legal instruments to control fluorocarbons. They cover throughout the life cycle. Ozone Layer Protection Act that covers this part. Sorry, this part, this upstream. And Fluorocarbon Emissions Control Act, this covers this area, prevent leakage emissions, recovery, destruction, recycling, and midstreams and downstreams. As you can see in this figure, HFC emissions have been increasing 2004. Yeah. That was mainly due to refrigerant transition from ODS to HFC. But according to the latest report, we saw a decline in 2022 here. This was the first decline since 2004. We appraise our various efforts under the Montreal Protocol contributing to the decline. Furthermore, we have a HFC emission reduction goal toward 2030. The goal is part of the global warming countermeasure plan based on the NDC and the Paris Agreement. To achieve 50% reduction by 2030 compared to 2013 levels, we believe the life cycle management approach is very effective too. Let's go back to the current state of HFC emissions. This figure shows a breakdown. HFC emissions account for about 4% of total GHG emissions in Japan, and about 90% of HFC emissions are from the cooling sector. Thus, controlling HFC emissions from cooling plays an important role in reducing HFC emissions and GHG emissions as well. This figure shows the breakdown of HFC emissions by equipment type and by life cycle stage. As shown in the left figure, more than 70% of HFCs are emitted from commercial refrigerators and air conditioners. This part, emissions from commercial equipment are regulated under the Fluorocarbon Emissions Control Act in Japan. As shown in the figure on the right, among emissions from commercial equipment, 55% are emitted during use and 44% at disposal. Leakage emissions during use are larger than emissions at disposal. Here we think preventing leakage emissions, especially including during use, is very important to reduce emissions. To reduce leakage emissions during use, we have the fluorocarbon leakage amount reporting system. Annual fluorocarbon leakage amount should be calculated by business operators in Japan. When total leakage emission during use exceeds 1,000 tons CO2, it must be reported to the government. Then let's move on to the current status of fluorocarbon recovery and destruction in Japan. Look at this line chart. This line, red line shows the change in amount of refrigerant destruction. And the line in black shows the amount of recovery. From 2002 to 2020. As you can see, the amount have been rapidly increased. Currently, we have approximately 52,000 recovery operators and 56 destruction facilities nationwide. Next, for recycling, we have 35 recycling facilities in Japan. The chart on the left shows the change in the number of recycling facilities and the amount of fluorocarbon recycled. The number of facilities steadily increased up to 1991. The amount of HFC recycled has been rapidly growing since 2020. The amount of HFC recycled has been gradually decreasing since 2019.
Well, now let's see the recovery rate. In this figure, the blue line, the blue part in the bar graph represents the amount of recovered refrigerant disposal, and the green part are maintenance. The black line shows the rate of refrigerant recovered. It has remained around 40%, and the latest rate was 44%. We are making strenuous effort to increase this recovery rate. This chart, the blue line in figure here shows the total number of inspections from 2015 to 2022. About 8,200 on-site inspections and 4,300 voluntary investigations were conducted up to 2022. In Japan, releasing fluorocarbons without good reason is subject to a penalty of imprisonment of 1 year or a fine up to 500,000 yen. We believe our measures and efforts will lead to an increase in recovery rate and reduce emissions further. That's all from me. Thank you very much for your kind attention.
Thank you, Miyake-san. This is one example of the legal system that are operated, especially with a focus on life cycle refrigerant management. Of course, depending on national circumstances, well, maybe something different can be useful, but still, we can learn from a lot from Japan's experience. One thing I just wanted to share with you during my discussion with my Vietnamese counterparts, well, they actually asked us like whether like a compliance rate in Japan is 100%, and we said no, not 100%, unfortunately. And then also some other colleagues, not Vietnamese but others, do you still need the law? Do we still need the law? Of course, for the raising compliance rate is very important. But before that, if you have a law, legal norm, or you have a clarity for people to follow, you have standard, you have a very clear set of actions that are required. Of course, it doesn't have to be a law, but in our context, well, the law was thought to be very appropriate. So that you discussed for like on the technical aspects 30 minutes ago, and then some of you already mentioned like I wondered what are actually specifications or what are requirements, what are licensing system for the quality of purified or reclaiming refrigerants. We have combination of government legal system and also like a private sector voluntary standard, but it's actually functioned as different layers. We don't have only one layer; it doesn't work at all. So we have a very general framework and more specified actions if you dig in to the ground. So that is something I just wanted to share with you with the invitation of Miyake-san. Of course, it's not so in that case, life cycle refrigerant management is not. We're not going to have a silver bullet, but you really have to stay and develop something, and then we really need to connect with other people. So that is one of the key features that we're working on. Yeah, so just wanted to supplement to his presentation. Before going to the presentation by myself and Mr. Ashish, I would like to invite Kasai-san to compliment a little bit about the the recovery rate of refrigerants, so that he kindly prepared very short presentation. Oh, 5 minutes, please. No, 5 minutes, please. Okay, Kasai-san, you can come. Okay, please.
Thank you, invited by Mr. Kato. This is a CFC plus HCFC plus HFC emission trend in Japan. Not only HFC, CFC and HCFC is also a strong global warming gas. Then Ms. Nakamura moderate group 7 and 8. The conclusion is ODS, CFC and HCFC is a problem. How deal with national determined contribution? ODS is a big problem. The cost of correction and destruction should be paid by carbon credit is a lot of opinion. But carbon credit issued after verification. Before verification, there's a destruction. Before destruction, there is a correction. But nobody pay correction or destruction fee. Then a lot of correction company cannot conduct correction. Then this is emission. Emission amount is calculated to several data. Then Japan collected notification data based on PRTRE law, CFC and HCFCs. This is a grade of the accuracy is different to, but totally next slide, please. This is a destruction trend in Japan. It is collected to each operator, each business company data aggregated to in ministry. Then after my presentation, Mr. Ashish explained recording system. It is easier to calculate emission amount. I propose to all countries this type of destruction amount fluorocarbons, including CFC and HCFC, attached to national determined contribution reference or the additional contribution. These three gases treated to same measures. It is, I think it is very important data. And international law neglect emission of ODS to global warming these 30 years. Thank you.
Thank you very much. Well, to supplement for his point, of course, HFC is very important for in the context of Paris Agreement, and that we're going to work on that. But to work to address the HFC's collection, destruction, reclamation, we also need to think about like ODS, including CFCs and HCFCs, because well, when you collect, when you recover, and when you collect, well, always, well, we have some portion of HCFCs. And then also like the economy of recycling business, you don't only work on HFCs, but also HCFCs, for example. So that I think his message is like we get the larger picture and how we're going to address both ODS and HFCs together. So that's my interpretation from his comments. Thank you very much, Kasai-san. Okay, now I would like to start my own presentation. And after that, well, we're going to have a very exciting demonstration of ODS HFC tracking system. So I am going to talk about the MRV. MRV, I am origin from the climate community, so that the MRV is kind of like a very common language to us. But MRV stands for Measurement Reporting Verification, or we call it transparency. So of course, well, we need to have ban, well, we need to have a bad punishment, but before that, well, like a transparency is a very big power because people are watching us, people are watching you, whether you are doing okay. If you're not doing okay, are you dare to dump anything like in the public? Probably no. Most people do not do that. So that is actually a power of transparency. Also, if, for example, the public authority government is watching you, and most people are actually, you know, they have different behavior. So that is something I just wanted to share with you in the context of refrigerants management. Okay. Okay. Oops. Oops. Okay. So as Miyake-san mentioned, well, we have different legal frameworks, but one thing is like important law legal arrangement is the Act on Rational Use and Proper Management of Fluorocarbons. Well, this includes key items for standardized and mandatory action. So as I mentioned, like law is not only banning something, regulating something, but you are actually informed by this law with certain standards and that's mandatory, and definition of key stakeholders' actions and their responsibilities. So that it's a mandate or it's recommended, but it's kind of like a standard. So think about when you are working on legislation in future, law has different aspects. And then clarity is actually very important for the private sector. Not only whether they're going to get like punishment or like they need to pay fine. Well, clarity is very important again. And then data tracking and transparency mechanisms. Well, we have this kind of arrangement. I don't have to go through one by one, but we have actually defined roles for in this act. For example, fluorocarbons, gases producers, manufacturers of equipment. So that by having this kind of this definition, well, they can recognize, okay, my action is this, my action is that. Probably the discussion in 30 minutes ago, because the frame of the discussion was quite vague, so that there was a little bit confusion, right? But if you have this kind of a specific mandate or specific roles defined, then it is easier for us to further think about like what are necessary actions or in the extension, right? So that is the behavior that is actually the flow of kind of like a mindset of Japanese private sector. Of course, we didn't actually, we took sometimes to establish this kind of system, but we have this definition. And further, we have equipment users. And we need we have registered fluorocarbon gases filling and recovery operators. You have servicing technicians, right? Those people are recognized by law. And in Japan, they are feeding by themselves by collecting service fees. There's not, 100% subsidized. They are doing for their business because they are recognized by law, and people are actually, with respect, we're paying for their service. So this is another function of this law, I interpret. And approved fluorocarbons gases recycling destruction operators, like I think Dowa-san, BPEC. I think in the Thai context for that, they are, something like this. Now in Vietnam, we're working on this. They have two destruction facilities already approved. But for reclamation, we're working. Well, we are looking for the first one to be approved. Yes. But for the approval of this kind of business, again, you need to have different layers of mandate, standards, specifications, and who is going to verify their validity of work. So that's something we have under this law. Okay, I am going to stop for like primary demolition contractors, collectors, and appliances. Okay, but the second feature of life cycle refrigerant management, yes, this is a life cycle. And I said like these players or these stakeholders, well, they are not in one company, right? No company will do this alone. Different companies, large companies, small companies, medium companies, they are working together. For example, for example, manufacturers of refrigerant gases and equipment manufacturers. But here, tomorrow we are going to go to supermarket to see refrigerant leakage detector. They have mandate by the Japanese law, and if they leak more than 100 ton CO2 equivalent refrigerant, they're actually obliged to report for the leakage amount or leakage event. And if they finish using refrigerants, or for example, when a building, if you demolish building, actually, before demolition, your contractors, you really need to report, okay, in this building, from this air conditioners or this chillers, we actually collected refrigerants before demolition. Otherwise, if you demolish a building with the refrigerants, and it simply goes up to the atmosphere, and it's happening in many areas of the world. But by law, we have this kind of procedure in clarity. Then we have, service. Well, you can actually see the equipments in this room, and then we have somebody like Hata-san from MZ. Well, he actually shows you what is the success factor of having refrigerants properly reclaimed in high quality. Then, if that is usable, then that is returned to the users. So that is actually a whole cycle, and we are working together. We're working together. So that is the concept of refrigerant life cycle management. Yes. I am going to skip this because it's already explained by Miyake-san. But just to check, even if we have this kind of framework or this kind of mandate, again, if nobody is watching you, people tend to cheat, right? So what is here is like we have small reports in each and every steps. If you have refrigerant cup and if you give your cylinder to another person, the next person, and if you give it your refrigerants, we usually weigh if you have like a 50 kilograms. And then the next step, if you have 10 kilograms, what are missing? So this kind of things are actually traced. That is very important. And well, this is a very busy one, but actually what the government has is this kind of like a reporting system electronically. And it's combined with the other reporting system, meaning like greenhouse gas reporting system. But this is very common. And also we have energy reporting system for 30 years, but it's combined now. Like this. Sorry. Okay. So that is our system tested for at least for 15 years or something. If you combine with the other reporting system, we have 30 years or 40 years history. But this time, well, we have started something similar in Vietnam. Well, Vietnamese people are very brave in initiating with this kind of things. And as I mentioned, we have started working with the Vietnamese government in developing the legal system. This is revised environmental protection law. And here you can look at this. So that in 2020, well, they have amended law on environment protection. That's more like a fundamental law. So you have very general description that you have to recover, you have to reclaim, you have to destroy refrigerants if you have bigger equipment. That's it. That's it. But further than that, they have developed decree on greenhouse gas mitigation and ozone layer protection. So they have more technical matters or implementation. I mean, this decree has procedures like who is going to do what in which order, who's going to report to which authority. But still, it's not enough. It's not enough. And we have circular, which is more in detail, and we have a national standard, QCVN, and it describes who is doing what. For example, I think Viraj actually mentioned like for the transportation of used refrigerant, whether it is for reclamation or whether it's for destruction, the laws applied to it is different. But this really affects the cost factor or the feasibility of shipping. So that kind of discussion took place for the last 2 years. And many of people here actually were contributed to this process. Yeah. Now we are working this area. This is actually extract from the same PowerPoint with that my Vietnamese colleagues. But again, in Vietnamese legal system, they have definition. Of course, mandate. But this is a definition. Who is responsible for what? To what extent? So that's important. And also steps. The collection is compulsory. Encouragement of recycle, reuse. Destruction is required for certain people. That is clear. So that that is already actually part of the law in implementation. Now, I said tracking. So it's similar to what you have worked. You have recovery from customer. I mean, some people, make a phone call. Can you collect my used refrigerant, or can you collect my air conditioner? You don't really want to bring this to dump into ocean or mountain. Otherwise, like MOEJ will come with a fluorocarbon police and you get arrested. It happened only one case in Japan. 2 cases already, but it's a terrible case. Terrible case. But then if your contractor will bring cylinder and they check whether your refrigerant is good enough for reclamation. As Hata-san mentioned, for the moisture contents, acidity contents, oil contents. And then even if for you, some refrigerants are good enough for reclamation, I don't think 100% is always reclaimed. Like at least like a 10% to 30% maybe are actually contaminated with acidity or those kind of things. So that you really need to divide like those which are going to be destroyed and reclaimed. But here, 18 kilogram, 18 kilogram, 18 kilogram, then you actually need to compare. You don't want to miss some amount. Maybe, well, it's already in the atmosphere, in the sky. So you don't really want to have this kind of situation. So that this is actually the life cycle management, and then very practical tracking steps. We used to have this tracking on paper-based. That is a terrible idea. That is a terrible idea. But in Japan started earlier, and we are not digital people like Koreans or Singaporeans or Indians. We started a little bit earlier, so that we used to have paper-based work. And then compliance rate, because it's very difficult, right? But now you have your iPhones, you have your Android, and you have RefNext. It's going to be introduced by Mr. Ashish, but because of this digital transformation phenomena, well, we have application tracking, like what are recycled amounts, what are virgin refrigerants refilled. Even if you have different stakeholders, you get the entire amount from I think maybe 5 kilogram. I don't know. Well, maybe, yeah. It's actually traced very clearly. And in Vietnam, for example, like so there are several tracking application like this. We work with different application operators, but Ashish-san's office is actually one of the major ones. Well, I heard there's some in European countries. Once we introduce somewhere from expert from somewhere from Slovakia, I think. In Indonesia, well, there are another one. But this kind of thing, it's very convenient. And again, we see very important role of the government intervention, because government set the law and government wants to see what is happening, whether even if they don't want to punish somebody, but they are monitoring what's happening. Of course, they want to report this to the UNFCCC or Paris Agreement or Montreal Protocol, but for the purpose of checking what's happening. Well, this is the first step. Then after that, your government people can decide whether or not there may be a new policy intervention. This is more like a evidence-based policy making. So RefNext or others can be used in the Vietnamese context. And then now with the support by the CCAC, I remember, Nathan helped us in developing this kind of proposal. But what we have done, we're now at the entrance point. But what we're going to start is that, we are actually modifying the Vietnamese government platform, electronic platform, and they can be fed by something like RefNext and other applications. So that this is quite beneficial for Vietnamese end users. They don't really have to do like a paperwork like what Japanese people did 10 years ago, right? So that is something I just wanted to share with you. And then now, Ash-san, can you show your system? This is more interesting, probably. Okay. Yes.
I hope no funny notifications come up, so I'm going to take that risk. Thanks a lot, Kato-san, for the humbling introduction. And yes, so before I get into the demonstration, I would like to. That's fine, yeah. And I'd like to just briefly share my experiences also, especially events like this organized by OECC. I had the fortune to, attend events by the Ministry of Environment in Indonesia. So one of the issues that they had highlighted was they are doing their IPCC, UNFCCC reporting. In that, not only refrigerant raw data, they need data to the granularity of what is the equipment type, right? Commercial equipment, residential equipment, whether it's coming from the automobile space. Then they even needed to the depth of whether this is an initial charge of the refrigerant already existing in the equipment or this is additional charge put in by contractors. Then they also spoke about bifurcating the imports and the refrigerant manufactured locally. So already, since we are struggling with basically capturing the the raw data, the basic data, this is the level of depth that was needed. Then in India, I was in a seminar where there's almost a fight between the private sector and the government, saying that whether the law comes first or whether the industry kind of streamlines itself first. It's kind of like a chicken and egg problem, right? I mean, so how do we handle this issue? Then we were just having a discussion today, and one of the very key points was data. Like, I mean, for policy, yeah, we need the data. For carbon credits, Kasai-san also highlighted that for acquisition of credits, it's kind of the last phase, right? I mean, they'll give you credits only after you have shown the data, not just raw data, but validated and verified data. So, I mean, already in these 3-4 minutes, you heard the term data so many times. So this is what I am kind of like, fanatically trying to create as a part of the RefNext initiative. So very briefly, if I can just, walk you through what exactly is the objective of this particular solution. So this is basically the same 6 steps that Kato-san had highlighted. So we have leveraged the great technology provided by the likes of Apple, Google. They have given us websites, they have given us apps. So we have basically just simply created an application that helps all the stakeholders come together. So Kato-san had mentioned there are so many stakeholders he listed. He looped through 4 slides talking about, there are product manufacturers, contractors, dealers. Now, all of these people are working in tandem to make this happen. Now, you need one place where they can come together and kind of, realize that what they're contributing, it's actually making sense, it's connecting to something meaningful. That is precisely what we are doing here. So these 6 steps talk about the stakeholders, starting from the customer, his building and equipment, then the dealer contractors connected together. So essentially, we start from the equipment, right? So we recover the refrigerant into small cylinders. We have QR codes on the small cylinders, which are then tracked on our system, which I'll briefly show in the demonstration. Then at the collection center, like Hata-san had also mentioned, we do the judgment. And then we continue to track on the system from the recovered cylinder, which large cylinder it was transferred to. Post that, we do either the reclamation or destruction. Now we need to also evidence that this reclaimed refrigerant, in the case of reclamation, is again put back into the equipment and it's not lying somewhere in the market for it to again, have the risk of getting into the atmosphere. So we manage the purity and then we transfer the cylinder refrigerant from the large to smaller cylinders, and then these are once again used back into the market. So this may all seem to be very complicated at first, but when we break down into steps, depending on different stakeholders, it becomes rather, simple. It's almost like your Amazon app, which I'll just show you. You have 5-6 steps. You just need to loop through that. And then you have automated reports and automated calculations happening. So very quickly, I will take you guys to the actual application. So this is how the app looks like. This is the web version of the app. I'm using some test accounts here, so please don't quote me on the data later on. So this is basically how the dashboard or the interface looks like. First and foremost, I'd like to highlight the users, right? I mean, as you can see here, you have administrators, dealers, contractors, field engineers, processors, all of them on the same platform. So this is your one-stop shop to know, whom you are connected to, who brought in the stuff, to whom this stuff is going to. Then comes the primary jobs that are, we can correspond on the application. As you can see in the active jobs section, you have recovery, process, recycle, dispose, rental and transfer, which is basically the transportation of these units, and then the fill job. So essentially the complete life cycle is covered in these job flows. I'll just give for a reference how the actual recovery job looks like. So you have a lot of data that's already pre-fed, like, mandatory stuff. When was the job requested? When was the job executed? Management numbers, etc. So you can have your list of contractors from whom you can select. And then, you have your customer and building. As you keep executing jobs, you will already have some data that is getting tracked, right? So I don't know if you guys have been to Vietnam. So Highlands is a very popular coffee shop chain. Yeah. So Highlands has some jobs that have been executed on Refnex. So this is just a test case, but you can see Highlands Coffee from Hanoi and Ho Chi Minh, both headquarters are registered here. So if I can just select this customer, and all the sites under this customer automatically show up. So it's that simple. So what we are essentially trying to do is, while we are helping contractors, technicians to register the data, we are also building a database of customers, their equipment, how much of refrigerant is there in those equipment. So essentially, we are automatically building the ODS bank, the refrigerant bank, if I may. Now, I'll just quickly show you how the actual, the jobs, what is the value proposition of these jobs. So I'll just go back fiscal year. Yep. So everything is here. You have your customer information, your building information, your management details, job numbers, the auto-generated certificates are here. So again, depending on the country, we just do an automated language support. So our base application is in Japan. So we have Japanese and English. In Vietnam, we added the Vietnamese language support. So for example, for the benefit of the audience, I'll just show the certificate. This is again a certificate that corresponds to the refrigerant law that dates back to 20 years back in Japan. So this basically outlines what all information is needed to be reported to the customer, to the contractor, and ultimately to the government. So basically, the Ministry of Environment had really, concrete and detailed information, detailed data going back 20 years. So like Kato-san also mentioned, people are struggling with documents, papers. So by March, the guy who had to calculate, he'd have this pile of paperwork on his desk, and he would say, I've heard companies say that they work for 3 months, like after March, April and May, they would spend these 3 months basically collating all of this data into an Excel sheet to upload it into the government website. So we have completely eliminated that 3 months of work for corporations, right? So these are certain reports that are auto-generated. You can see the language support. This is supported in Vietnamese as well. So basically, what is it that we are actually doing? So you can see here, we have already classified the equipment based on the use case. For example, we are tracking commercial ACs, refrigerator freezers, and others, which include car ACs and home air conditioners, because home air conditioners do not come under the refrigerant law in Japan. This could be a different case in other countries where they may include home ACs into the main law. So then that would have its own section. So basically, this level of data granularity will help countries to automatically pull data from a platform like RefNext and plug it into their IPCC, UNFCCC reporting. Now, for each equipment in detail, we are tracking what is the total recovery volume. We have like the equipment details, right? I mean, you have your brand. I'm sorry, it's just a test case. I am not promoting Daikin, although they are my largest customer here. But sorry. So you have your scroll chiller, you have your models, and then for each equipment, you have your complete cylinder list, how much was recovered from it, and it also tells you from this recovered cylinder which cylinder was it transferred to. Essentially, traceability is visible to all the stakeholders in the workflow. So this automatically brings reliability onto the platform. This automatically brings validation into the platform because you have a certified collection center or a reclamation center telling you that you recovered 20 kg. That is 18 kg. It became 18 kg by the time it came to the collection center. And maybe it was 16 kg by the time it was reclaimed. Ideally, like Kato-san mentioned, that should not be the case. 20 should translate to 20 kg of dispose or reclamation. But then, I mean, so this helps you to understand, okay, so this particular transportation route or this particular contractor has some issues where there is a refrigerant loss between the recovery up till the reclamation. So all of these are minute, intricate stuff which, we get to see or we get to know only when this level of a depth of a system is in place. So I think I will try to wrap up my presentation by just giving a last minute overview into the detailing of the data that we are kind of tracking on the system. So I apologize for the Japanese that's coming up there, but the one on top, the Japan cumulative, is the annual accumulation. Below that, you have state level accumulation. So in Japan, you have like within the country also, each government, so they're called prefectural governments. So each prefecture has its own reporting structure. They have actually, it's a funny story. They have their own format of reporting as well. At the end of the day, the data is same. I'll just show you very quickly. If sorry to take more time, but basically this is in Japanese, but it basically talks about CFC, HCFC. The structure is basically the same. But then, each government would want to have its own kind of, data on top. And so now, again, like if you have a contractor who's doing jobs in 6 prefectures, okay, that guy now has to file 6 reports, which is kind of crazy if you think about it. But then, they don't want to be spending that time, right? I mean, instead of spending a couple of days there, if he would be doing 2 more jobs, he would be earning more money. I mean, that's how the business runs, right? So we are trying to eliminate these type of menial tasks for contractors so that they can focus on their main activity and they can leave the whole headache of data accumulation, calculations, and also verification and validation of the data to platforms like this. Down the line, we envisage to put in technology like blockchain. We are already working on it to ensure that governments have even more conviction on our platform, saying that, I mean, we can just directly use the data. Like Kato-san mentioned, we want to ultimately share this data directly to Vietnam's DCC platform or MOEJ's digital platform. So once we have blockchain in place, that's when they'll be like even more convinced that, this is kind of reviewed and okayed by all the stakeholders in the workflow. So that brings me to the end of a very quick, but hopefully brief demonstration of the RefNext solution. Thank you so much, guys. It's been
Thank you very much, Mr. Ashish, for that's really eye-opening. Eye-opening a moment that you presented for the RefNext. What time is it now? Sorry. Okay. We still have 30 minutes, and maybe a little bit tired, but you can get back to the team, and please consider the legal aspects or institution aspects. Many of you are from the government, so that and also some others are from the private sector. Please think about what are roles by the government. For example, think about you are going to develop your own legal system. Introducing all this electronic tracking. Is it something somebody else will prepare everything for you? For example, the formats that Mr. Ashish showed. Of course, he nicely laid out topics or items to be reported. But that is about the design. But the decision needs to come from the government. And we have a very intensive discussion, for example, in Vietnam. What are topics that are like a mandatory filing? That is basically decided by law or like a regulation or attached documents. And that is something we are going to adjust with RefNext and Vietnamese national platform. So that's something we are actually working now. Please think about you are working on you can probably because we don't have so much time, so you can focus on maybe some point, but either destruction or maybe shipping. But what are things you have to do in the development of the law? And let's spend only 15 minutes. And so maybe we can probably spend wrapping up what were discussed. It doesn't have to be exhaustive, but I would like one of your team members to share maybe 3 or 4 minutes what were discussion, what are not clear, what are potential areas that we should work. So that's something. This is going to be kind of like our souvenir from this discussion. So let's go back to after that. For you have a nice dinner and beer and conversation. Okay, thank you very much. Okay. Any questions? No. Okay. All right. So we are going to start a reporting session. So you can either stay. Maybe you can stay your around the flip chart. If you can do your reporting. I think you need to have more time to have a complete discussion, but you don't really have to have a perfect conclusion. Yep. Okay. So each group representative is requested to spend 3 to 4 minutes to explain what are discussed and also what are lessons learned. Okay. We're going to have a reporting session, and each representative will spend 3 or 4 minutes to explain what you discussed and what are lessons learned and what are the missing points that we can work on. All right. Okay. Now, which group will be the first? I think if you go for earlier, well, it's easier. Okay. Okay. Group number 4 and 5. Ashish-san. Okay. Okay, please. Please pay attention to the report. Yeah.
Okay, so I think I'll keep it very brief.
Yes, please.
So yes, sir. So primarily we were able to touch upon a lot of points. Again, to reiterate, we identified that a software for MRV is very critical to understand what is happening. A kind of a central repository collection method, these are very critical. And we also had some kind of pointers about, in especially developing countries, there is a lack of hardware, right? Like recovery cylinders shortage. So how do we address those problems? However, towards the end, the conversation kind of more shifted towards even through today, we spoke a lot about technologies, how different countries are facing what issues, but probably the discussion did not go so much towards the business modeling side. I mean, where exactly is the merit points for the stakeholders here to willingly participate in this whole scheme, right? I mean, and we have been talking in terms of a business perspective, like, when we do the recovery, as per the Japanese law, contractors can earn money because the customer pays them. However, in other countries, it's the exact opposite, right? I mean, you'll have to buy back the refrigerant from the customers. Then there is another issue of ownership transfer, because when you talk about carbon credits, that becomes a very critical aspect, like who is the owner of the refrigerant, right? So over there, we kind of were brainstorming on one aspect is how much of a value proposition is there for the end user, that is a customer. Can we include the customer into this whole loop of stakeholders and consider? Because so far, in different law mandates and stakeholders that we spoke about, we have not been talking about the customer, right? I mean, so I'll just very quickly tell the reason why, because obviously when we talk about large scale real estate companies, refrigerant is a very small aspect for them compared to energy usage, etc. However, as one of the LCA studies that was publicized by Daikin as well, usage of reclaimed refrigerant reduces their carbon footprint of the refrigerant amount by about 1/7. So that is a good amount of CFP reduction if they are going for building certification, etc. So when we look at big customers having a portfolio of 50 buildings, 100 buildings, or 20 buildings, this can be a reasonable amount of value. So can we entice them to purchase reclaimed refrigerant at a higher cost because they are gaining some benefit from the carbon footprint reduction? But how do we evidence that, and how do we put a number on that, this procedure, right? So this is something like we just brainstorm. We don't obviously have a solution here, but I think that could be a good point for discussion. That's about it from our team. Thank you.
Thank you very much. Now, next team, I hear the volunteer from group number 9. Okay. Then Yamanaka-san first, then.
I would like to finish first. Sorry, I would like to explain, what we discussed. Our discussion was not very broad, entire, covering entire in the process. We were talking about in Thailand there is a regulation for the factory only, right? So and then proper management is necessary. And in Japan, all users are covered, and all users are needed to, implement proper management of the refrigerant. And then in Vietnam, the regulation says that, as Vietnamese government explained that, bigger size of the equipment can be covered by Decree 6, but smaller ones can be covered by Decree 08, which is, talking about ERP, that is the extended producer liability thing. And then also the smaller one is covered by WEEE. Right, so this is not for the refrigerant, but for the all the equipment for the recycling. And then, starting from there, and then Malaysia, there is a regulation for the certification for the technician, but not regulation for mandate to recover the refrigerant. So now, if there are certified technicians, if there is no regulation for, recover the refrigerant, who is going to recover it? That's the question. So we have to have the, balanced regulation, and then, the regulation has to cover entire, supply chain of that refrigerant. And then we needed to understand the necessity of the collection site and the distraction site and then the reclamation site. And then all of them has to be registered, publicly registered, because, they are eligible to report how much refrigerant recovered, and how much refrigerant they get, and how much refrigerant they sent to other places. And then also in the collection site needed to have a analysis capability to determine refrigerant should be distracted or reclaimed. That kind of capability they needed to have. So there is a question whether there should be some kind of a guideline, what refrigerant should be distracted or what refrigerant should be reclaimed. That kind of the discussion we made. So that kind of registration system is also necessary. And then for the distraction side, distraction needs to have some expertise and also facilities, special facilities. Is that a good idea to have such distraction facility in all countries, even small market? So it's really, it's a questionable thing. So it is not economically feasible. And then, it's very difficult to sustain that distraction facility for the smaller markets. So there should be some way to send the refrigerant for the distraction outside of that small country to other countries where capable of distract such refrigerant. There is no good answer for it, but we'd like to identify, that is the question to answer. And then for the distraction, maybe credit, carbon credit can cover the cost of entire scheme. May not cover 100%, but it can be a good source of that cost coverage. However, if that is the case, people tend to send the refrigerant to distraction only to get the money, even though the refrigerant can be reclaimed and then reused again. But, we needed to identify, why we needed to have the reclaimed refrigerant. So we have to think about how to create the demand of the reclaimed refrigerant. And some of the government said that, currently virgin refrigerant price is really low, so that no need or no value of the reclaimed refrigerant. So we needed to find out how to make the reclaimed refrigerant value increased. So maybe in order to do so, carbon credit could be the way, but it seems to be difficult at this moment. Maybe we should ask the government to mandate the use of reclaimed refrigerant in some way. But it may be difficult for the manufacturers. We are from manufacturing side, so it's a kind of difficult. But all those we have to think about until. Due to the Kigali Amendment, in the end, reclaimed refrigerant demand will increase anyway. But until then, how can we sustain reclamation site? So that is the important part. So I'm sorry, but we cannot come up with the answers for all the questions, but we tried to identify what we should tackle. So that is the end of it.
Fantastic. Thank you very much.
Thank you.
Okay. Okay. Then okay. So okay, then okay, please.
So for ours, at first we identified what the needs that would fall under all the categories. So one of the main things is regulation for the life cycle of refrigerant management. And under that, there's going to be business models, funding, and technical assistance, APR. It'll basically cover the whole life cycle management, the life cycle of the refrigerant. And then the regulation and policies is gonna, the life cycle and policies is gonna be tailored because each of the government is gonna come up with their own regulation. It's gonna be tailored specific to their country, right? Because not all our countries have the same capabilities. So for using and recovery, some of the things that we identified that we would need are recovery machines, pump down for split AC, policies and incentives, certification of technicians, guidelines, and quotas. For intermediate collection sites, we have QA/QC analyzer, standard cylinders for collection. And then from the intermediate collection site, we go to destruction and we put, it's paid by the users. That's who's gonna cover the cost. And then specific Tech 8 specs for permit and carbon market. And then from that intermediate collection site, it goes to reclamation as well. And under reclamation, we have a reclamation facility, cylinder for reclaimed refrigerants, licensing and QA/QC certificate under whatever standards the country decides to go follow. And then from the reclamation, as you can see, we wrote our own arrow back to destruction because from reclamation, sometimes they don't pass the certification, so they have to be destroyed. From reclamation, back to the market and cooling equipment manufacturers. One of the 3 points we had was design low carbon technology, have tax incentives and transfer to low GWP tech and refrigerants. So for the tax incentives, we put that there for people that are changing from another refrigerant to another technology or machinery that uses a low GWP, they would get like a tax incentive for their purchase. And then from that, it was back to using and recovery. We have proper installation, leak detection, mechanical joint to prevent leakage. And that was all.
Okay, thank you very much. Okay. We have 2 more groups. Which one goes? Okay. Yes? Okay, group number 1.
Hi, good afternoon. So I'm not going to remember everything, but so first of all, the one who will keep track of everything will be the Department of Environment. So there are issues in some countries regarding separate units of ozone and the Paris Agreement, the climate change. So we want to fast track or keep the coordination going with them. So so we have that one unit for international commitments, and we'll use the online tracking system to be funded by the government. So for the users, we have a reporting system, but since it's going to be difficult for small-time users, I think we included here. The big users will be first to be included here. So for the recovery, we have requirements for their permit. So included here are what equipment are they allowed to use, and they should be trained, and the reporting system. They should be using the reporting system. And then, so the training conducted for these would be paid by the ozone unit or project supported by international agency, and the skills are standard ISO 22712. So we actually bypassed the market manufacturers because we usually just import the. But yes. All right. One issue was how would we help the users to transport their HFCs until the destruction or reclamation? Because they can just sell it to the black market. Because but one idea was, actually the first idea was in Europe, they could, ayan. So the users buy it, and then the added tax will be paid to the collection site. So that was the idea earlier from Europe, but it will not work because, as said by Ms. Hild. So the alternative idea is, after they buy, they can give the used equipment back to the manufacturer, and the manufacturer will be the one who will be paying the intermediate collection site. So the arrow will be like that, then go back here, then that will go to the intermediate collection site. And other idea is to track the flow of money. So ideally, we want to use, we want to, not force, we want to motivate the users to transport their waste to the intermediate collection site. So either we use the government funds to motivate them to transport it there, or we can fund the manufacturers to motivate the users, but it's a longer arrow. So I think that's all. Okay, the reclamation and for the destruction, we also gave economic incentives to do the reclamation or destruction, and the initial cost support from coordination of local government and international agencies. I think that's all. Yeah.
Okay, thank you very much. Okay, final group.
So what we discussed in this group mostly is about in this stage of using and recovery, refrigerant identification, and also using weighings, some sort of weighing mechanism to check the weight of the recovered gas. And also we spoke a lot about making a business out of the whole LRM. So basically for example, establishing like a business model, making it into a business model so that more SMEs would be willing to participate and make a profit possibly out of this. So for example, people would need to have an incentive to join and to carry out this process. So for example, training programs, involvement of vocational programs and institutions, and we could also support it by giving information for startups, so providing a business model and how it works and profits and incentives. And so ideally, of course, the sales of the reclaimed gas should be financing the business. So also to elaborate, so more on seed money and giving grants. This does need to be self-sustaining. Yeah, so that's mostly about the business aspect of it. And also we discussed about having EPR policy in place, but this might be challenging, especially for lower volume countries, and also countries who do not have a manufacturing in place. So in this phase of intermediate collection site, it spoke about having a space for analyzing whatever gases come in, and yeah, and possibly a standard is established for how to identify as well. And for the destruction, let's go to the carbon. Yeah. So yeah, the EPR policy to support the destruction as well. And in terms of reclamation, we were thinking about in terms of places which have space constraints. So also for the businesses to provide support in giving them space and equipment to carry out this reclamation. So yeah, that's all.
Okay, thank you very much. So now this comes to the ending part of today's session, day one. I think everybody's a bit tired, exhausted. Thank you very much for your contribution. I think now you see I see your face of exhaustedness or confusion or like a bit of frustration, but I think still you get some sense of life cycle refrigerant management and also like a challenges existing. Also, what we have heard is there are not, of course, well, there are some commonalities or some maybe minimum requirements or minimum framework, common framework, but also like a different approaches by different countries. So this is another thing. So we can highlight. Today, the purpose of this discussion is not bringing us to the perfect answer. But it's rather than that, we're going to unpack like a complexity of life cycle refrigerant management, but still we can identify different pieces, different elements that we should tackle. So that is actually what the purpose of discussion. So sorry for getting you so tired of this, but I think I am very successful in putting you in. in this discussion, and I really want to thank you all for your active engagement in the discussion. So today we talked about the entire picture of life cycle refrigerant management and like some legal aspects, technology aspects, and also country situation. And tomorrow we're going to jump on to the economic aspects. So that's another challenge where we should actually tackle. And then also very challenging carbon market mechanisms approach. That's not the only answer, but that may be one approach we can use. So with this, are there anybody who wants to say something? No? Okay. With this, with this, I would like to conclude today's discussion. Thank you very much for your participation.